Thank you very much for the organization of this amazing event. And I'm going to talk about a project we did for NGI on TikTok, so the social media. And this project is run by two non-profit organizations, both Tracking Expose and Algorithmic Transparency Institute, work on algorithmic accountability, and basically both projects create free softwares to allow user to scrape their personalized feeds and in general to support researchers, journalists, and advocacy organization in the effort to understand the impact of social media algorithms. We also had the chance to collaborate with Milano University and Amsterdam University, particularly the Media Studies department. So we are not two universities, but we managed to work with universities. Just super quick background. Basically, the algorithm of social media are proprietary and trademark secrets, and basically it's not possible to access them in order to study them, especially the one of TikTok. And our question was about the different algorithm used on TikTok web and TikTok mobile application. So what is the methodology we can use to study those two different applications? And in general, the question was about, is the algorithm the same? Can we use one of the two application as a proxy for the study of the whole platform? Because, for example, web app is way easier to be analyzed compared to mobile app, but we are not sure it is the same. This is particularly relevant because even if the Digital Service Act is now approved and it requires to have mandatory independent audits on very large online platforms, at the moment, TikTok does not have a public API, so there is no way to get data from the platform in order to study it. Even if other platforms allow a researcher to gather data, none of them have yet a reliable way to test specifically the algorithm. Basically, what we tried to do, what we did was to combine the infrastructure realized by Junkipedia on one side and Tracking Expose on the other side into a cross-application analysis. Junkipedia created a API reversing tool to study the mobile application, while Tracking Expose built a passive scraping tool for the web app. We used Sock Puppet Orchestrator, so a software able to orchestrate research accounts across both mobile and web. And what we did is basically building a methodology to compare the two applications. Going into the analysis, we realized that our two infrastructure were not enough to get the work done. And this is when we involved the University of Amsterdam that realized the Zane-Schumer application. And thanks to that, we were able to cover all the different sections of the TikTok platform. Really quickly, the methodology involved creation and personalization phase. So we created many accounts, we personalized them using a common procedure across web and mobile. And here I put an example. For example, we use 100 cats videos to train, to personalize some of the accounts. Then what we did was to measure the personalization across different sections of the platform. So, for example, after watching 100 videos of cats, we went in the For You page, so the homepage of TikTok. We scrolled the home page and we collect all the recommended video and we count how many of them were related to cats, and if on mobile and web application we received the same recommendation, basically. This was really important. We needed some iterations. We need to improve the technology on one side because our collecting methods were slightly different and we want to have something that is exactly the same. And we also have to deal with some methodological issues because it was not possible to reproduce the same classic personalization we used to reproduce on the different applications. So we needed to create a third methodology that was able to run across the two infrastructures. Going to the conclusion, basically we found modest yet relevant differences at two levels, the infrastructure level and the algorithmic level. So at the infrastructure level, we saw that the two applications are built for different scope. So the web application is more for content creators, so it doesn't have some explore section. While at the algorithmic level, and this is obviously the most important result, we found a significant difference between the level of personalization received on mobile and on web. So the web personalization seems to be way lighter compared to the one on mobile. So basically the conclusion is they are similar, but they are different. And in order to have a complete and comprehensive algorithmic audit of the TikTok algorithm, we need to study both, possibly with the same infrastructure and possibly with the same mechanism for personalization and collecting evidence. Basically, what we are doing after this project is end, we are now developing a common infrastructure, a common across the European organization and the American organization, that is able to solve this problem, and that is supposed to be somehow a standard for the study of this platform, especially now that the Digital Service Act will be implemented, let's say, in the following months. And that's it.
Can I ask a question? I have two questions. One is, I'm not familiar, I mean, at my age, I'm not so much familiar with TikTok, okay? So, but the fact that you mentioned that the mobile part is more personalized, is this because of the location information, dynamic location, so that things are targeted depending on where you are, or it's because the interface is smaller, or do you have? And the second question is if you could elaborate a little bit more on the collaboration with the US and why there was an added value in this collaboration, how it worked, and what was your feedback?
Thank you for the question. So I will start from the second question. It was crucial because there is no many organization building this kind of software. So we wanted to build a collaboration among the two, let's say, most developed infrastructure to monitor TikTok. And one was in the US, the Junkipedia one, and the other one was in Europe. So without this combination across, let's say, the two organizations, it wouldn't be possible to actually answer this question, no? Because each infrastructure requires months to be developed and a certain amount of money, and no one did both at the same time. So we needed to get together to answer the question. Regarding the first question, that was I didn't took note. Now, can you?
You mentioned that the mobile one is more
Why?
personalized
Yes.
than the web one, and
Yes.
the reason for it?
So first of all, so the two applications are created for different scope. The audience of the two applications is very different. So most of the people use the mobile application, like I would say 99%, let's say 95%, but most of the people, while just content creators use the web application. Content creators and old people use the web application because they are less familiar with the mobile, or because they want to post-produce some content and then upload them with the computer. This is the first reason. So they have different target and different scope. The second reason, it's also probably that the web application is way easier to be analyzed, and it's possible that we see more general and generic recommendation over there because this is, let's say, more safe to expose in that way. Okay, so this is a possibility. Obviously, we unfortunately don't have any answer from the platform, so they refused to comment our research, and they didn't answer this very specific question when journalists asked them, and that's why we needed this research, basically. But it's also a possibility that they don't want to expose the real algorithm in a more accessible way, and this will force us to work more on mobile application and mobile reversing and mobile scraping.
Yeah. Thank you very much. This is a very timely research because, as you mentioned, with the DSA, this is going to become more and more important, and there is going to be more and more work on this. Let's hope that at the end we get some outcomes.
Yes. We plan to have the new infrastructure ready for the beginning of, let's say, the implementation of the DSA. So that was the plan.
The purpose. Thank you.
Thank you very much.
Thank you, Salvatore. You sort of answered the question I was going to ask a moment ago, but maybe I'll just ask it anyway. When you were doing your analyses on both the web and the mobile versions, did you have any contacts with the developers or the company itself, or were they cooperative? Were they not cooperative? Or were you able to do your forensics without them in the loop, so to speak?
I would say definitely not cooperative. First of all, the most efficient way to collaborate would be to open an API. So they could allow researchers to access data. This is not the case. There are other platforms doing similar things, like Twitter used to have a quite good API. Now Elon Musk closed it. Facebook used to have a quite good API, even if some data in crucial moments were missing. So it was a tricky problem. In few months, it will be mandatory for the platform to answer researcher, answer journalists, provide access to data, and even provide access to the code. So provide access to the code of the algorithm. No? This is not the case yet, and I'm afraid they will wait till the very last minute before to give access to this information. And even then, we are trying to build a technology that is not relying directly on their data, but is somehow using scraping or reversing techniques so that we can be kind of sure that what we see is not manipulated by the platform itself, but it's a real behavior. No, and so I hope they will give us some access and some answer. But even if they will not, we are in position to say we will do our research anyway, and that's, let's say.
Okay, thank you, Salvatore.
Thank you.
Any other? Yeah, we have a question from the room.
Okay. Hi. So thank you so much for your research. Fascinating. I'm working on disinformation operations myself at the moment. And I was wondering why you chose the cats to train the algorithms and not some other more politicized subject.
Yeah.
Identity-based.
Yes, no, we did use different topics. So we basically used the cats, it was an example, and we use it as a control. But we did use French political content, specifically candidates channels. And we also compare it with the basically we reproduce the same methodology with the same issue, the same topic, political topic in Italy and France. So you need to consider that this research is very geolocalized. So different countries, different recommendations. I quote CAT because I mean we use it as a control group. We use it to make the control group because it's known that it's a really huge category on the platform, so it's really big, and it's really easy to code a video talking about cats or not, because if you see a cat, it's a cat video. While for political content it was more tricky. We wanted to do that, so we also added some qualitative analysis to the results, but with cat it was way easier, and it was the way let's say the comparison, the term of comparison we use for political and non-political topic, because political topic is really small on the platform while cat is huge. So we also want to see like a different magnitude order, no, in the number of recommended video that we got in the For You page. Yeah, but basically the results were constant. Obviously the scale was 1 to 10, so every 10 cats video you get one political video. This is quite normal, but there is also a relationship, the same proportion is when we compare mobile and web. So on web we always receive less than half of the recommended video according to the topic we were studying, and leaving aside the fact that the two objects studied had like different magnitude order. So that was the complete explanation.
Sorry, I have a follow-up question. So when with the cats, you found a certain number of recommendations once you've trained the algorithms, but did you find that proportionately for the other groups, for example, political content, the algorithms were more aggressive, or was it comparable?
No, it was constantly, let's say, the same for the same type of application. So it was the same on web and the same on mobile, but political recommendations are way less, even if you watch the same amount of videos. So for example, I watch 100 cats video, then I go to the For You page, and among, let's say, 10 recommended video, 6 of them are about cats. If I do the same with political content, I watch 100 political content, and then I go back to the For You page, I watch 10 videos, just 2 of them will be, no, less than half. 2 of them will be about politics, because political content is way smaller bubble on the platform. So the content that can be recommended are less and are less powerful. So they have less engagement and they are less recommended.
Okay, thank you so much. Thank you.